Hello students, in today's lecture of CAD CAM, we'll discuss about transformations. CAD CAM in this, transformations is our topic. Now transformations are of two types, two-dimensional, three-dimensional. Let us focus on two-dimensional transformations. What exactly transformations are all about, okay? And we'll see the application point, how does it help a CAD system. Okay, transformations are all about computer-aided designing. The modeling software could be CATIA or Creo, Unigraphics or any other software. But in all these softwares, we'll try to create a part model followed by an assembly or a drafting. While creating a part model, we'll try to draw a 2D sketch followed by a 3D model. Now, once the 3D model got developed, to have a proper look, proper visualization of that particular component, we'll try to rotate the component, we'll try to zoom in and zoom out the component, we'll try to increase the size of the component, reduce the size of the component, or we'll try to reflect the component, many other cases, okay? Or we can move the component also, we can translate it, translation is also possible. So broadly, these 2D transformation or 3D transformation classified as, if I'll take the first one, translation, second one, rotation, third one, scaling. These are the three terms which are very much important. Now all the software are inbuilt with matrix multiplication formats. It is already fed to the system. That is the reason whenever you would like to translate an entity or a component, it is done automatically. Whenever you want to rotate, that can be done automatically. Whatever the command you give, whatever you want to do or perform, that can be performed easily with the help of transformations in 2D or 3D. That is very much possible with these terms. Okay, let us see each and every term individually, what exactly translation is all about, what is rotation and what is scaling. Okay, other than this, you have few more. For example, reflection. Okay, number 5, shearing. Okay, now based on the academics, we'll try to focus more on translation, rotation, scaling, in some cases reflection. Okay, now we'll see what exactly translation is all about. We'll try to know the concept of transformations in this particular video lecture. First one, translation. For example, there is a coordinate system 0, 0, this is x direction and this is y direction. Okay, there is a point, there is a p x, y. Now I would like to translate or move this particular point from the original position to a new position, which I'll name it as p prime, which is called x prime, y prime. Okay, this can be done automatically in case of any of the modeling softwares. But what is happening behind the screens such that it is reacting in that way? Whenever you would like to translate with some x amount with some y amount, negative or positive, it is doing your task. Whatever would you like to perform, it is doing your task. But what is fed to the system actually, it is reacting in that way. Okay, matrix multiplication formats, what we call, that is fed in the form of a programming. That is the reason system is reacting to your whatever the commands you give. Okay, so in translation, this is our question. For example, point P from the old position need to be shifted to the new position. Okay, if that is the case, prime, y prime need to be calculated, x prime and y prime, because x prime and y prime are new positions. If that is the case, if I just add up the original position with the new, you'll get the final answer. For example, x plus tx, x is old position, tx is a new coordinate point which is given to you in the question, y plus ty. Simple. X plus tx, y plus ty. If I consider this as equation number 1, this as equation number 2, the same can also be written in a vector form, matrix format, like p is equal to x, y, according to the sketch whatever we have drawn, and p prime is equal to x prime, y prime. This is the new point. And what is the transformation or translation here? Translation going to tx, ty. If this is the, this can also be written as p prime is equal to p plus t. This is the final equation that we can, okay, p prime is equal to p plus t. Simple addition. This kind of program is already fed to the system. That is the reason this program or a system is reacting to this particular translation. If you want to shift an entity, could be that entity could be a point, or it could be a line, it could be a rectangle or any other spline, etc. Okay, 2D, we are talking about 2D transformations. So this is how we'll do addition, simple addition. Okay, and one more, coming to the rotation part, rotation number 2. Now here in this case, translation also, tx, ty given to you in the question, xy will be given to you in the question. Only thing is we need to add up both the things to get the final coordinate. Simple, very simple method of addition. Number 2, rotation. In case of rotation, again we'll consider a simple sketch. X, I, this is the origin point. Now again we'll try to consider a point P, x comma y. Now this need to be rotated. For example, initially the position of the point is at, let us take an angle of phi. Position, initial position of point P is at an angle of phi with respect to the horizontal. Now this need to be rotated. The same point need to be rotated with some angle where you get a new point or a new coordinate with respect to this. Okay, now let us consider this angle as theta. Okay, now this new point, I'll try to name it as P prime, the way we have seen in translation, P prime, which is x prime, y prime. Okay, this is the concept, simple concept. I would like to rotate a point P, which is x comma y, to a new position P prime, x prime, y prime. We need to calculate this x prime, y prime, the way we have calculated for translation. Okay, in a similar fashion we need to calculate. Now if such is the case, now here it is a simple addition, but whereas in this case you find angles, phi is one angle, theta is the another angle. Okay, we know from the basics that we need to calculate x prime followed by y prime. Okay, now whenever it is it represents horizontal, we consider it as cos, and vertical we consider it as sin theta, because we are maintaining an angle of theta here. Okay, let us write in this format, r cos, what are the two angles, phi plus theta, r cos, because phi and theta we are considering. Okay, similarly r sin, when in terms of direction, phi plus theta. Okay, let us consider this as cos a plus b, sin a plus b. Okay, if it is cos a plus b, what would be the formula? Cos a cos b minus sin a sin b. So r cos a nothing but phi cos theta, cos a cos b minus sin phi sin theta. Okay, here also we need to show r. R is common for both the things. Similarly, sin a plus b, cos a sin b plus sin a cos b, r cos a sin b plus, here I'll continue, r sin phi cos theta. This is the formula. Cos a cos b minus sin a sin b, cos a sin b plus sin a cos b. Okay, now if this is the case, now x is equal to r cos phi and y is equal to r sin phi. Okay, x is equal to r cos phi, y sin phi. You can write for this particular angle, which are polar coordinates. Now x is equal to r cos phi. If it is r cos phi is x, now you can consider this r cos phi as, similarly sin, r sin phi as y, this one, this as y term, this as x term. Similarly the other equation x and y, r cos, here is a cos, this is x, and sin, this is y term. Okay, simple. Now this term is y, this term is x, this is x, and this is y. If that is the case, if you replace those, for example, if I consider these two as equation number 1, x prime y prime, these two as equation number 1, then the second one, x is equal to r cos phi and r sin phi, I'll consider this as equation number 2, okay, which are polar coordinates. If this is the case, now I can substitute this in terms of x and y. I'll substitute x and y for r cos and r sin, x prime y prime. We rewrite the equation again. This becomes x cos theta minus y sin theta. Similarly, sin theta plus y cos. Okay, let's consider this as the third equation. Okay, now the same equation can be written in this format, simple format, like x prime y prime is equal to x prime y prime is equal to y, I'm taking it common, followed by cos sin cos. Okay, x terms and y terms, I'll try to write it separately, x and y terms. Cos, I'll try to show it as c theta cos theta, and s theta sin theta minus s theta sin theta, nothing but cos theta. X and y terms, I am trying to rewrite x and y terms, that's it. Okay, now rotation can be indicated with r, capital R, followed by the same equation, cos theta sin theta minus sin theta cos theta. Okay, this is the equation. Now the same equation can be rewritten in this format, which is prime is equal to P multiplied by R. This is the equation. In case of translation, we are trying to add up. In case of rotation, we are trying to multiply the matrix with the given coordinates. Okay, this is how we'll do. This is the final equation actually. So nobody will ask you to derive. They may give you a question based on rotation. Point x comma y is placed in a coordinate system and need to be rotated with an angle of 45 degrees or 30 degrees. So if that is the case, you need to consider this as your matrix. You need to remember this matrix followed by whatever the value given, 45 degrees or 30 degrees, that is multiplied again by whatever the coordinates given. You'll get the final product. Okay, we'll discuss this when we come across few problems related. Okay, similarly, if you take the third one is all about scaling. Okay, scaling could be done in two ways. Like we know from our basics, like the scale could be enlarged scale or a reduced scale. It all depends on the value given. Okay, if you multiply it by a bigger number, if it is 1:2, nothing but we are scaling it down. If it is 2:1, we are increasing the scale. That is the meaning we know from our basics. In a similar fashion, for example, if you consider a simple sketch of this kind, there is a coordinate system, 0, 0 is the origin. There is a point again, or let us consider this time a simple square box, which is, let us take this as 1, 2, 3 and 4 corners. This is y-axis, this is x-axis, 4 corners. Then again, now if you want to, you have developed a square of 1, 2, 3, 4 with some dimensions. After that, if you want to enlarge the scale, increase the size of the square size, so that can be done by scaling operation, matrix multiplication format again. If you increase, the size may be of this kind. Okay, if you decrease, maybe the size of this kind. Okay, it all depends on the value given to you in the question. It all depends on the value. For example, we'll take this concept again, same concept, whatever we have considered for that. Now we need to calculate x prime followed by y prime. Okay, the way we did for translation and rotation. Now x multiplied by sx. Now x is the coordinate given to you and followed by sx is the value where you need to enlarge or reduce the scale of your matrix or a quantity. Okay, y multiplied by sy. These are the two values given to you. Only thing is you need to multiply. Okay, but here we have to write the same in matrix form. Okay, now this can be written in this format again in the equation form, like for example, p prime is equal to p multiplied by, s is the notation, or a capital S is the notation, stands for scaling, multiplication. Here also multiplication. You have to observe one thing. In case of translation, we are adding the coordinates. In case of rotation and scaling, we are multiplying it. Okay, this is a scenario. Now the same terms can be written in a matrix format for scaling, sx 0 sy. Okay, now this matrix, if you have to remember this matrix multiplied by given coordinates will give you the actual product. Okay, resultant coordinate system or resultant matrix. And this value sx si you can reduce or enlarge uniformly or non-uniformly. Let us see the similarities between translation, rotation and scaling. If you look at scaling and rotation, both the equations what we got is multiplication. Okay, the actual matrix or a coordinate is multiplied by rotation or a coordinate given to you in the question. Similarly in this case also, whereas in this case it is addition. Okay, because of this addition the process may slow down. Because of this translation addition, the complete matrix multiplication program or a calculation becomes slow down, because when you have multiple tasks need to be attempted. Okay, for example, the part need to be scaled, then again it need to be translated, then again it need to be rotated. Okay, then again scaling. If this is these are the multiple tasks, out of this scaling, rotation, scaling, all these are matrix multiplications. Only this particular term translation is addition. Because of that systems get slowed down complete. We need to do each and every calculations. You can't do it as a multiple task. Okay, this is a problem with addition. Okay, this addition can also be avoided in the name of homogeneous coordinate system. Okay, that we'll discuss in the upcoming classes. This is the only concept related to transformations. Okay, translation, rotation and scaling, and almost all without which none of the softwares exist. Okay, all these are fed to the system. That is the reason system will listen to the person who is operating it. Manually you can rotate the component, translate the component, scale the component. This is the concept. Try to remember the equations and the matrices, which will help you to calculate few problems. Okay, we'll continue with transformations. We have already seen the concept of 2D transformations, where we discussed about translation, rotation and scaling. Today we'll try to solve few problems based on it. Simple problems based on 2D transformations. Okay, let us consider a coordinate system. We'll try to solve a problem based on translation, okay, let us consider as the coordinate system, which is x and y. Okay, now let us consider a triangle 1 2 3 or ABC. Okay, now this need to be shifted. For example, from here to next level, this need to be shifted to a new point. Let us name it as 1 prime, 2 prime and 3 prime. This is our problem. Okay, now we will consider some conventional coordinates, numbers, and we'll calculate the problem. Now the problem is something like this. We would like to translate a polygon, triangle nothing but, with coordinates a is equal to some 2 comma 6, b is equal to some 7 or 8 comma 10, and is equal to, let us take it as some 10 comma 3. Okay, a b c, nothing but 1 2 3. Okay, now this need to be shifted to a new position. Let us take that new position as 4 units in x direction and some 3 units in y. This is the problem. There is a polygon ABC of given coordinate need to be shifted to a new position, 4 in x, 3 in y direction. If that is the case, we need to find x prime, y prime. That's it. In a similar fashion, now we need to calculate a prime, b prime, c prime. Individual, I'll just make you understand. If I consider this as a prime, then the formula is going to be a plus t. Okay, if what is a now? 2 6. If this is a plus transformation 4 3, because x is 4, y is 3. If this is the case, 6 9 is your solution. Okay, in the similar fashion, if I'll consider prime, b plus t is the equation, the way we have seen in the concept. That is equal to, what is b now? 10 8 10 followed by same matrix again 4 3. Then what would be the final matrix you are going to get? 8 plus 4. Similarly, if it is c prime, c plus t, that is equal to c 10 3 plus again 4 3, that is equal to again 14 by 6. Okay, you got ABC now. This is your new position. Okay, now that new position can be written in this format. Translation, new translation matrix is something of this kind, which is 6 9, then 12 13, then again 14 6. This is your new matrix. Okay, new position means this is a prime, b prime, c prime, 1 prime, 2 prime, 3 prime according to the sketch. Okay, this is how we'll do. Fine. Similarly, we'll try to solve one more problem based on rotation. Second problem, let us consider second problem as rotation. Okay, we'll consider a simple sketch, x and y, 0 is the origin, 0 comma 0. Okay, now there is a point. Let us give a number as 5 comma 2. There is a point P. 5 comma 2 need to be rotated to a new point. This need to be rotated to a new point, which is P prime, that need to be calculated. Okay, now the angle between these two is already given to you in the question, 45 degrees. Okay, which is theta is equal to 45 degrees. That is the case. Okay, now how to frame a question against this? How to frame a question? You can easily frame the question just by looking at the sketch. Okay, now a point 5 comma 2 is rotated counterclockwise direction, because here it is rotating counterclockwise direction at an angle of 45 degrees, and find the matrix, rotation matrix, and the resultant point. That might be your question. Okay, you can frame your question just by looking at the sketch. Now it is rotating counterclockwise direction. Whenever it is rotating counterclockwise direction, we know the matrix, cos theta, sin theta, minus sin cos. Okay, now we are working on xy plane, so that is the matrix again. Now what is the matrix we have developed? Here we have developed a matrix of this kind, cos theta, sin theta, minus sin theta, cos theta. This is how we will develop. Okay, if this is the case, again what to be done? Theta we know, point is given already. So what I try to do is, I'll try to substitute cos 45 degrees, sin 45 degrees. Okay, similarly minus sin cos. Now 45 means it is 1 by root 2. We know from our basics. What is that? 1 by root 2 minus every other thing remains the same. This is the equation. Once you got this equation, again you need to set it to prime, p prime. That can be done simply if I'll say p prime is equal to, a point is given already, 5, 2 in a matrix form. Then again multiplied by the equation we got. Okay, if you multiply these two, you'll get the final product. Okay, final product. That's it. That is your solution. Very simple. Okay, now in a similar fashion, again we'll try to solve one more problem based on scaling. Simple problem based on scaling. We'll consider a simple sketch. For example, there is a coordinate I, x. Okay, now there is a triangle. Let us consider this as a triangle. Okay, I would like to enlarge the size of this particular triangle, but not uniformly, for example, but not uniformly. We'll see what is uniform, what is non-uniform also. Now this need to be shifted something like this. It need to increase its size, something like this. If I'll say A, B, C, this is A, B, C, and the next point going to be A prime, B prime and C prime. That we need to calculate. We need to reach that particular level. Okay, now let us consider this as our sketch and we'll try to frame a question against this. Scale a triangle ABC. A is equal to, let us consider a coordinate at this particular point A. A is equal to some 2, 4. Similarly, B is equal to some 10, 3 and C is equal to 7, 10. Okay, 7, 10, 3, 10, 3, B 10, 3, 10, 3, then 7, 3. Okay. Or else you can shift this CB also, not a problem. I have given bigger number here to B and smaller number to C. The triangle won't be like this. It may be of different shape, but ultimately it is going to be triangle only. Okay, you can shift, not a problem. We are just discussing the concept. Okay, these are the coordinates. The polygon need to be shifted 2 units in x direction and some 4 units in y direction. Okay, this is the question. 2 and 4 is the question. 2 in x and some 4 in y. Now we know from the concept S is equal to Sx 0 and S. This is the matrix. This matrix has to be multiplied with the whatever the coordinates given. Now S is equal to, this becomes, when we rewrite, Sx is given to Sy is 4. In x nothing but Sx, in y nothing but Sy. Fine. Now if this is the case, now we'll try to replace Sx, Sy with 2 and 4. 2, 0 and 4. This is the matrix we got. Now this matrix need to be multiplied with ABC. Okay, like for example, what is A? 2, 4, again 7, 10, sorry 10, 3 and 7, 10. This is the actual coordinates given to you and this has to be multiplied by whatever the matrix we got, so that you will get a final product. 3 terms. If you multiply simply this row by column plus row by column, row by column, you will get the final answer. Okay, this is how we'll do simple problems. Okay, now all 2D transformations, whether it is scaling, rotation or translation, all are very simple problems. Okay, you find bit difficulty when it comes to 3D transformations. Now here in this case, in case of rotation, the matrix will never be cos sines minus sin cos all the time. It all depends. Now as we are working on xy plane, rotation is with respect to z axis. With respect to z nothing but it is exactly perpendicular to the origin. Z is going to be perpendicular to the origin. In such case, this is your matrix. Now this matrix will change if it is with respect to x, if it is with respect to y. Matrix and this particular coordinates cos theta, sin theta, minus and cos will also change its position in that particular matrix. Okay, this is all about transformations, 2D small simple problems. If you have any queries, let me know. Comment on the box given below. Thank you for now.